Hello, fellow classmates. I'm Ryan Arrison, and my partner Jacqueline Elliott will be working the computer screen. Today we are going to discuss the double displacement reaction of sodium hydroxide and nickel 2 chloride. A double displacement reaction is a reaction in which the ions swap atoms to form new substances. We will begin the experiment by obtaining two 50 milliliter beakers from the container shelf and placing them on the workbench. After retrieving the 50 milliliter beakers, we will add 15 milliliters of 1 molar sodium hydroxide to one of the beakers. After measuring the first reactant, we will add 6 milliliters of nickel 2 chloride solution to the second empty beaker. It is observed that the solution of sodium hydroxide is clear, while the nickel 2 chloride solution is green. After observing the reactants before the reaction, the contents of 50 milliliter beakers containing sodium hydroxide are completely emptied into the 50 milliliter beaker containing nickel 2 chloride. The reaction of sodium hydroxide and nickel 2 chloride forms a precipitate in a clear solution. The clear solution contains dissolved sodium chloride. The precipitate is observed to be green, and the precipitate of the reaction is nickel 2 hydroxide. In the PowerPoint, we have included a solubility chart. From this solubility chart, it can be observed that the hydroxide ion is insoluble when combined with the nickel 2 ion. It can also be observed from the chart that the chloride ion and the sodium ion are soluble. Therefore, sodium chloride is an aqueous compound. The green precipitate in the solution can then be concluded as the nickel 2 ion. The balance equation of the reaction of sodium hydroxide and nickel 2 chloride can be seen on this PowerPoint. On the left-hand side are the reactants with 2 moles of sodium hydroxide and 1 mole of nickel 2 chloride, both of which are aqueous. Over on the right-hand side, the products are 1 mole of nickel 2 hydroxide and 2 moles of sodium chloride. Sodium chloride is aqueous, and the nickel 2 hydroxide is a solid. Thank you for listening to our performance of Experiment 4.